Bon après-midi à tout le monde. On est de retour. Alors, j'ai eu des bons feedbacks sur la matinée, donc je suis très content. Personnellement, moi, je suis ravi. On a vu un éventail d'applications et des choses à apprendre qui étaient impressionnantes. Donc, c'était vraiment très enrichissant. Et j'espère d'inspiration pour des futures collaborations et pour des belles opportunités à venir. Plus proche. Et je ne bouge pas. C'est impossible. Je vais dire, c'est bouger, c'est pas. I will switch to English in a second. Donc, disons que si on a bien fait notre travail ce matin, on est tous d'accord que la caractérisation, c'est quelque chose de grand, c'est quelque chose qui va au-delà du cliché des microscopies électroniques ou de la simple analyse d'un spectre. La caractérisation, ça veut dire fiabilité. La caractérisation, ça veut dire vraiment safe by design pour les matériaux, mais aussi analyse des défaillances, tout ça pour vraiment augmenter notre possibilité de faire de meilleurs produits et de cette façon contribuer au succès de l'industrie et aussi un retour beaucoup plus large pour la société. Donc dans cette séance de cet après-midi, on va la commencer par une intervention du Conseil européen de la caractérisation. C'est un conseil qui a été établi justement pour porter la caractérisation en tant que sujet au cœur des instances européennes et de la discussion dans ce sens-là. Et notamment, c'est un institut qui s'est un peu distingué pour le développement d'un système, d'une modalité, si vous voulez, des management des data qui prend ses fondations sur l'outil CADA, C-H-A-D-A, qui est un outil que je vous invite, si vous n'avez jamais entendu parler, d'aller voir, parce que ça inspire en fait d'une collaboration très étroite entre les conseils de la caractérisation et les conseils du modeling, et qui a été un peu devenu les standards adoptés par la Commission dans tous les projets qui sont en cours. Et l'autre très, très grand travail de ces groupes, ça a été la roadmap la roadmap de la caractérisation et ses applications industrielles et surtout à l'interaction avec l'industrie qui a été publiée avant le Covid et qui aujourd'hui va devoir voir sa mise à jour. Et du coup, de tout ça, vous aurez parlé Kostas Charidis, qui malheureusement est malade. La grippe est en train de faire des ravages partout, donc est arrivé jusqu'en Grèce. Donc ça sera avec nous. Il a accepté le défi et maintenant je passe à l'anglais. So welcome to Georgios Konstantopoulos from the National Technical University of Athens, who is going to give this keynote on basically the European Material Characterization Council initiatives, future, but also what has been done in the past. I think it's the right place, this conference, Carac', to talk about what has been done and also how all this community can contribute to what you're doing. And of course, Georgios is going to ask you some, let's say, homework. Of course, not for now, but when you're back in your institute, because the coming survey for the future roadmap on characterization is out, so you're all welcome to participate. But I don't want to anticipate too much. Georgios, the floor is yours.
Ennio, thank you so much. Thank you for the introduction, for having me here. So today I will present the European Materials Characterization Council, EMCC. So the presentation today will be separated in three sections, starting with the history, the vision and the mission of European Materials Characterization Council, and also discussing in brief the outcomes of the roadmap of 2017. So this is the board of European Materials Characterization Council. European Materials Characterization Council was an initiative to support policy making, so give strategic directions for the next European work programs and support the industrial needs. The vision of EMCC is about the green and digital transition of industry. So EMCC presented in the roadmap of 2017 the vision for open innovation environments, which are user interaction interfaces which enable to provide service directly to the industry in terms of characterization and also modeling, with a lot of projects funded in creating European innovation test beds. And in continuation of that, EMCC has a triangle which combines characterization, data science, manufacturing, and modeling, which is actually the tool to give the solutions needed for the industry. And also, as Ennio mentioned, the CADA, this is data management methodology which was introduced by EMCC and the standardization workshop. This is key ingredients for the digitalization and planting the seeds for the digital materials passports, which will include details on materials qualities, state at a specific point of assessment. With the roadmap, EMCC managed to fund several activities which included open innovation platforms and projects which adapted the characterization data structure CADA scheme for the data management of characterization, which document the methodology. Funded several projects which are around open innovation test beds, so services directly to the industry, bringing together academia and giving access to SMEs. And also several projects working on real-time characterization, advanced characterization and harmonization of characterization were funded, and recently about the integration of modeling and characterization schemes as a service. These projects are over 20 European projects which are now the ecosystem of EMCC, and working together on common challenges to propose unique approaches across EU. And also EMCC collaborates closely with the European Modeling Council, the Advanced Materials Initiative 2030, which also asked for consultation from European Materials Characterization Council for the upcoming policy framework for the next work program. For addressing the common challenges, 5 working groups have been created and implemented, which are around instrumentation and methodology, about standardization, protocols, regulations, and safety, and also characterization data and information management, as well as a working group dedicated to the industry needs, and another working group about policy and clustering activities of EMCC. Going to the second section of this presentation, we will see the key enable role of characterization and some examples about the CADA activity. First of all, characterization is quite important as I can provide the data which can be used for material selection, and also the characterization data can be very important for optimizing manufacturing processes by giving feedback and adapting to the new parameters of a manufacturing line. Also, it is really important because it can give us information about material state. So, if material can be reusable, what is the next action that this material should be implemented to. So, for example, does it qualify to reuse? Does it qualify for another application to a secondary market, not the same application? So all this information can be granted from characterization activities. And also it is pretty important because several characterization methods can provide safety information about materials. So going into one example, first of all, the characterization methods, data documentation and data exchange procedures were documented in a workshop for standardization by CEN, which was initiated by MCC and the Project Oyster, which is about bringing together experts and agreeing on a common standard, which is about how to document a method, which are the essential steps which should be documented by every expert to make the method reproducible. So this is one key outcome, which we can see an example what applications can serve, because we have in the experiment the sample preparation, we have then the characterization method, which includes the calibration and the testing, and then we have the raw data acquisition, and then the metadata upon subsequent application of models, which could be, for the example of nanomechanics, contact mechanics models. And we have to consider that each application may have some unique settings. So, for example, different microstructures and different materials require different settings of the characterization method, a different model to be applied, different data post-processing. And this requires to be documented, so to be material specific. Also, the example of nano-indentation, it has a lot of tuning and knowledge of the user, which, for example, can enable to perform measurements at high speed and throughput at high strain rates, which should be applicable only under specific circumstances. So documentation of such protocols and data analysis methods is really important. And here we can see some impact for different industries, for example, concrete industry, or for thermal barrier coatings, or for studying the microstructure of fiber-reinforced composites. So it is quite important to know that each specific material, due to its unique behavior and time-dependent deformation phenomena, requires different and unique tuning of the protocol parameters. So it is quite important to document this information and make it accessible to industry in an open innovation platform which contains this knowledge. Going forward, or maybe to add something about the previous topic, it is about the next step of this is the ontology development, because this is a physical form which needs digitalization in order to communicate with user interfaces and capture this knowledge and the interrelations of the specific protocol parameters tuning, and when for a specific case the user wants to do specific characterization for a concrete, what sample preparation it is required to do, information about sampling and post-processing. So this should be captured in a digital form and be integratable in an interoperable manner in an open innovation environment, in a database. Going to the next topic, this is about the future challenges for EMCC and advanced materials characterization in Europe. So In June 2023, in Lund, Sweden, European Materials Characterization Council organized a special session in the key event of Forum 2023, where EMCC presented 8 pillars which are identified of key importance for the next work programs and policy activities within Europe around characterization, which include standardization, the data management governance around characterization activities, artificial intelligence and modeling, advanced characterization methodologies and automation, the characterization hardware hub, which is about the test bed offering services directly to the industry, and also the industrial hub, which is quite important that the emerging and priority actions reflect the needs of industry and especially cutting-edge technologies. So, in June, we started an open consultation process. We received the first feedback from the audience of Forum, and now we proceed with the second step in the consultation process, which is a survey. So, this is a survey with a QR code. You can access directly the survey in your phones or computer. This survey will take you only 16 minutes, and we invite you to give feedback because so far we have collected 50 replies from stakeholders, including 10 different industries. We will need as much engagement from the community so that the consultation, which finishes at the 10th of December, will be most representative from the community needs and industrial aspects. And also don't miss the opportunity to give your own feedback because beyond specific selections in a multiple choice form, we have provided an open field where you can submit your suggestions, which we will also take into consideration. Now we will see in these slides some key outcomes from the survey. First of all, we asked the community to rank the proposed pillars and to suggest new pillars if they see a need, a different need. So far, the pillar with the highest selection was about novel advanced methods in automation, focusing on the analysis throughput. So the data throughput was in the core of priorities set from the community. And of course, we have the standardization of methodologies, which is still quite important and emerging. And after that, we have the artificial intelligence methodologies ranking. But still we see that high throughput data generation, this is in the core of the interests. And about critical challenges, the ranking was to establish standard methodologies on multi-scale characterization. So this was the need that emerged through the survey. And then we see the ranking about digital procedure for merging different multimodal outputs of characterization, and about the standards and coordination in materials data infrastructure, data exchange procedure, etc. Yes, and about the data management and data governance, what was indicated as first priority is about working about metadata schemes and materials definition with the European Materials Modeling Council. This was the most critical aspect that was ranked through the survey. And then it was about the standardization for metadata for characterization and simulation. And regarding the characterization data sharing, the first critical challenge is about platforms and populated databases with characterization model data. Then second, establish schemas for linking characterization data with modeling of material properties. And then the availability of experimental materials metadata as input for simulations to validate materials models. So still we see that even some projects have been funded already by European Commission in the previous work programs to develop materials databases and open innovation environments. Still there is a need to structure, maybe in different domains from the project funded, materials database and provide access to that. Also regarding the integration of artificial intelligence and modeling tools, the first priority was about developing and integrating artificial intelligence toolboxes in order to treat the big data, especially from large-scale industrial plants and also regarding in-situ characterization activities. Regarding the development of novel advanced methods and automation, we see here again a similar feature to the previous outcome of high throughput characterization. We see that the community needs fast and reliable characterization schemes, which will be able to treat, also to provide the data for treating the information needed for inline inspection of production. And finally, we will see this last slide about the survey, about the establishment of European Characterization Hardware Hub. And we see that the first priority is to give access to industries and SMEs to characterization and modeling services. This was the top priority ranked. And about the establishment of digital platforms for industry, we see that integration of characterization and data analytics tools within a European materials platform is the first need, with a vision to make one short stop for the user. And mainly for industry, because it is envisioned industry to be the main user. And going to the next slide, we will see that here, these are the steps for the industry interaction with academia and large-scale facilities for access to services of characterization. And this was presented in June from Alpha Laval, which identified two key areas of secondary markets of characterization as service, which is about providing the experimental environment and expertise, and about the data analysis of the test data. And we can see that, first of all, the experimental environment can trigger the development of methodologies to organize the knowledge, like the ontologies. And also, it is required to provide accessibility to know-how in order to develop trust between the facilities and the industry. So this is a first secondary market for characterization as service. And the second one is on the analysis of test data, which requires the documentation of methodologies for data analysis and the digital tools to provide rapid analysis, because another bottleneck for industry is that they may go to characterization facilities, but the data analysis might take too long to provide the feedback with the actual results, and so that the industry concludes on the experiment and implements any changes needed in the production lines, for example. So we can see that those secondary markets of characterization as service are closely connected to the digital product passport, because this is one place that we want to document the information of the state of the material. for the common data spaces, because this is the platform where industries and stakeholders can share their data so that they can have access to historical data of specific materials and support the optimization procedures in manufacturing, and also to support the materials design and selection. And also we can see that here this is also closely connected to the standard methodologies, standardized methodologies which are material specific for industrial needs, which are all core of the European work programs which fund the current projects and will fund the next research projects. In conclusion, characterization as service can have quite important impact in the materials development and circularity, starting from the material selection, because materials data are quite important in order to optimize the manufacturing parameters, and also considering alternative feedstocks, more sustainable feedstocks, which require still to comply with high-performance standards. So materials data are quite important for design activities, which are also quite important for efficient resource management, so that we can envision zero-waste manufacturing. Also, by documenting characterization data and have the specific footprint data of a material, this can enable the reduction about the need of physical characterization by the aspect that the pattern between structural properties can be captured through artificial intelligence and novel modeling approaches, which can substitute part of probably the certification schemes of materials manufacturing. Also, regarding materials health monitoring and extension of service life, it is quite important characterization to provide the feedback because to assess the state of the material related to the standards of the application and indicate secondary applications upon potential materials reuse. Finally, the key activities on characterization data management will support the needs for reduction of the physical waste in terms of digital information, because unnecessary experiments may be avoided by using proper data management and utilizing the knowledge stored in ontologies, so that we perform the characterization as necessary. And also reduce the digital waste, because many of you may face that a lot of characterization data are produced, and you need quite large storage sizes in order to manage this. So having a proper data management method is quite important because this will be an issue for the future. The summarizing slide is on key activities of European Materials Characterization Council. EMCC has participated in Advanced Materials Initiative meetings and surveys, giving a consultation on the roadmaps published through AMI 2030. Also, EMCC organized in the International Workshop of the Modeling Council in April the Materials Characterization Modeling session. And also in Euro Forum in June, we organized the satellite event in the main program of Advanced Materials Characterization on digitalization materials. Now, two upcoming activities. First one will be an exploitation event in Madrid in 17th of January, where we will have multiple industries invited in our activity, which will aim the European projects to present their innovations to industry and conclude on key activities, key outcomes of the project activities, so that we have a clear landscape of the policy for the characterization and the next priorities based on the outcomes of the projects. Finally, through the project Nanome Commons, EMCC will be supporting a new CN standardization workshop, which will be on the data exchange procedures for creating an ontology, so that going from the CADA, the physical form, to the digital form, and implementing it in databases so that we can, in an interoperable manner, upload the ontology, which will organize the data and the methods data. So that's it. Thank you so much for your attention.
Thank you, Georgios. Any question from the audience? Okay, I see 1, 2, 3. I start from the closer one.
Thank you very much for the presentation. My main question is, I'm not sure I understand who are the members of this initiative and how they impact the industry in terms of link to material providers, to process developers, systems. Can you clarify a little bit who was at the initiative and how you plan to disseminate and scale up to the industry?
Yes, thank you for your question. EMCC is aiming on the activities focused on characterization. So the main target group of the industry is actually, it reflects many markets of Europe, including aviation, automotive, and material components for other applications from additive manufacturing. So it is focused on the process, the industrial plant. So we are focusing from the idea conceptualization of the material to the development of the material. So, I mean, it is, of course, focused the supply chain for this one. And we gather the stakeholders, also academia, research facilities, SMEs, which are focused on providing characterization as a service. I don't know if I answered your question, but do you want to do a follow-up?
Yeah, you can hear me? Yes. Okay. Thank you so much for giving us the opportunity to participate to this talk. Maybe 2 short questions. I totally agree with you that it's important that service providers are included in this type of discussion. But I'm wondering, regarding your survey, you have already received some answers. Do you have any idea about the profile? Are they mainly from academy, or are they also coming from industry? And how do you plan to disseminate this survey to have a very broad overview of all different types of sectors that are interested in materials characterization? And my other question deals with the connection with some regulatory issues, because this is also one of the main challenges that industry is facing. How to answer to REACH, for example, and to produce materials characterization data to answer to REACH. And I have not seen so much detail on this, so I know it's on innovation, but yeah, so profile of answers, and on the other side, connection with regulatory issue.
Yes, so we have already received over 50 answers. Out of them, about 25% is from industry, and a smaller percent is from SMEs. The rest is from academia and research institutes. Currently, we use our channels in LinkedIn, our official website, and also our collaborative networks, such as the Materials Modeling Council, and we have forwarded the survey to Advanced Materials Initiative, which is, let's say, the wider umbrella about the materials policy, which includes also key working groups about characterization and modeling, trying to address as many members as possible. Also, through our LinkedIn channel, we have over 300 members. So, okay, it is not perfect, but at least it is something. Regarding the reach and characterization nanosafety, this is something more specific topic for nanosafety cluster, because we have a collaboration channel with them. But it depends on the material-specific applications. So in nanomaterials, in some materials, the toxicity is driven by the zeta potential, by the size of the material, and such project to measure such properties have been already funded, Path for Nano and another one, I don't recall right now, which are members of European Materials Characterization Council, but also members of nanosafety cluster. But it is a more specific activity to nanosafety.
Okay, that's good. Third question, Athanasios.
Yeah. Hi, Yorgos. Thank you. Can you hear me?
Yeah.
Yeah. Thank you for the presentation. Probably you have mentioned, and I missed it. What's the purpose of the survey, and how you're going to use it? It's pretty much related to the previous question. How you're gonna use the results? You're gonna help you to design the next roadmap, or I don't know.
Yes, thank you for your question. The survey has the scope to drive the key priorities in order to construct the new roadmap. So, EMCC published last roadmap in 2017 with the vision for 5 years. So now we are gathering the community in order to publish the new roadmap, which will be based on the survey key priorities with a further analysis. And as soon as this document is ready, we will publish it in our website and social channels for public consultation for 1 month, so that to make sure that we have collected the needs and the priorities from the community, and also additional feedback to have a representative document for the next 5 years. Also, this document will be quite useful, because in the next work programs, actually in the next 2 years, I think, they will have specific actions about characterization, modeling, and data management. So, by publishing the survey and some results, at least in the end of December or start of January, will be quite important to shape these topics. Because if you see, the Advanced Materials Initiative has already published some list of priorities in the characterization domain, which we have the opportunity with this survey to shape a little bit and make it more reflective of the community needs.
Okay, we have the last question. No. Yeah, in this case, let's thank the speaker again. Thank you very much, Georgios.
Thank you. And of course, don't miss the opportunity to visit the website and register
sorry,
as a
Georgios. I have a feedback. We have some questions from remote.
Oh, okay,
so you're going to have for another round of applause. Thank
you very much, Ennio. I was ready to come to the floor, and you gave me the opportunity. Thank you very much, Georgios, for your presentation. So we have one question for you and one question which is more a broader question for the audience. The first question is, are you looking for new experts to contribute to EMCC roadmap and web packages?
Yes, absolutely. So EMCC is opening this consultation process, and what I have to clarify is that the previous roadmap was quite useful to create the working groups, which were required to address the common challenges in the characterization domain across Europe. So now, since we launched a new road mapping activity, this means that the working groups will be revised as well. And this opens the opportunity for the community to express their interest also in leading working groups. So absolutely yes, we are open for new members, new experts to join EMCC activities, and also to have a more active role and a say in EMCC.
Thank you very much for this comment. So we do have a question to the Assembly. How to take part in characterization and data analytics tools within a European materials platform set as a one-stop shop? Je ne sais pas qui...
So it's a general question for... it's a general question for everybody. I think the obvious answer is everybody has his recipe. In some cases, we have more structured collaboration. In some cases, a bit more looser, going just down to a consortium, like, for example, the Platform for Advanced Characterization in Grenoble. But if the question is, instead, how we are going to coordinate all the effort, all this wonderful capacity that is today here among all the IRTs, where we discover our complementarities and complementarities and also redundancy in terms of capacity, then I will invite who asked the question to wait until the end, because we are going to have the wrap up with the directors, so we're going to need more to know more. Okay, so thank you again, Georgios.
Thank you so much.
And then the next, now we go for the next round table. So I would like to invite here, can we have the next slide with all the list? Okay, please. Yeah. I would like to invite here on stage the participant to the next round table, which is about how characterization can help to speed up sustainable development. So, Veronica. I cite them in order of proximity, and then your name are going to show on the screen, of course. Antonio, since you're here. Exact. So Lars, where is Lars? Lars and Julien. Thank you very much for joining. So each one of you can take a microphone, and then my microphone I will share with Julien. Okay, very good. So next slide, please. C'est moi qui ai le truc? Ah, ok, très bien. Ok, juste pour... on va faire aussi cette table ronde en anglais. Et si jamais... ça va bien pour tout le monde? Ok, très bien. Sinon, j'ai essayé de faire des traductions de temps en temps, mais ce n'est pas la peine, on va juste casser le rythme. Ok, très bien. Et alors, Julien, your presentation is in here, so if you can just introduce yourself in 2-3 minutes, just to tell us about who you are, what you do, and what your ambition and your contribution in the sustainable development.
All right, okay, so I'll do the presentation in English for my colleagues in here. So my name is Julien Munoz. I'm in charge of the polymer and composite team at the RT Saint-Exupéry. So in 2 minutes, I will try to be very synthetic. So I would say we work at the early stages of development of new product. So it implies that we support the design, and mainly we develop new materials and processes to reach a given specification. It ranges from thermal aspects to acoustic damping. Again, it's very related to the specification of our partners. I would say that it brings 2 challenges. The first one is to improve the knowledge of the process and the impact of the process on the final material. And the second one is, of course, to be able to explain what phenomenon occur when you put these new materials in a real environment, some real constraints. So you both understand that characterization is part of our daily routine to achieve these challenges. That's okay. I'm okay. I guess it was shorter than 2 minutes. So.
Thank you very much. And then Antonio, it's up to you to introduce yourself. Welcome.
Thank you. So I'm very happy to be here in this assembly. Thank you for the invitation. Why I'm here? I'm working in a steelmaking company, in a small, big steelmaking company. We're producing 1.5 million ton of steel for construction. And why I'm here? So it's because we are one of the most important field in the circular economy. So we are our process begin with scrap and is ending with waste that we are in most part 70% recovering. We are recovering heat from electrical furnaces, our process, most important process for the production of steel, and for giving the possibility to implement it in the district heating and for the heating of our buildings. We are recovering, our process, at the base of our process, there is the recovering of something. We are recovering the 90% of water in our process. We are recovering energy in our process. But what is important in this moment in order to achieve the goal of the sustainable development is to make an effort in order to recover better our waste and transform it in secondary raw materials and find new implementation of this. So we are working a lot on that, and at the base of that there is the characterization of the waste, the characterization of the raw material, the secondary raw material, what is there is transformed, and the characterization of the process at the base of the transformation.
Thank you. Thank you very much. And now, Lars, please. Tell us about yourself.
Yes, hello everyone, good afternoon. Thank you very much for the invite. I'm very happy to be here. So my name is Lars Oberbeck, I work for Total Energies. I'm an expert for renewable energies, and part of my time I'm spending at IPVF to do techno-economic and environmental analysis, specifically of PV technologies that are being developed at IPVF.
Thank you very much. And dulcis in fondo. Veronica.
An introduction in Italian. So my name is Veronica Lattanzi, and I am the scientific business manager of a big science center at the Danish Technological Institute. It's a no-profit organization, it's an RTO. And what we do is we work at the interface between large-scale research infrastructures in Europe, but not only, and mainly the Danish industries, but of course also from all around Europe and abroad. So we are a service provider, and I have personally a team of experienced scientists. And today I'm also representing the first European project called Remade at ARI, where we are leading the industry innovation work package for 7 key business sectors in Europe. And we have 3 calls now opened for industries to apply, but also for the knowledge providers. And with knowledge providers, I mean universities, but also RTOs. So if you're interested, let's have a chat after these roundtable discussions, because I would love to guide you through this offer that the project is offering to everyone.
Thank you very much. And you can see the website here. But we're going to discuss about this a bit more in details after. Okay, so why we're here? Basically, when we started the organization of the roundtables and the program, we thought, okay, characterization for what can be used. Everybody think many more easily about all the process of characterization, like very well was shown by George before with all the process and etc. But what is for, and what is for that is important for society? And we thought that sustainable development was actually one of the sector and one of the application where we would like really to see if there is an impact. and if this impact is there, which one is it? And if we think about this, in this respect, we organized this roundtable a bit following, if you want, the value chain, because sustainable development is recycle, reuse, and... Oh, really? Repair. Okay, so it's not all for me as a material scientist. It's only recycle. But we thought there was not only this. So in this respect, we thought, okay, if we want to organize some expert, which kind of expertise we want to find, and in this respect, we asked Veronica to be here and tell us very much about how large-scale facility like synchrotron, neutrons, analytical research infrastructure can really contribute to this challenge, in particular in industry. So, in respect to Veronica, this is what we're going to ask her after. But then, when we think about Julian is one of these very bright scientists with a long career that spent a huge amount of years trying to find the best material on Earth with the most performant property. And now we are changing completely is challenging. We say you don't have any more to do a very good material. You just have to take what you have and make the best out of it. And then when we think about Lars is going to talk about life science cycle and life cycle and everything that is related with all this process. And finally, the reason why I asked Antonio to intervene is because among us was the only one that was basically going into the waste management side and how to make waste again something useful and not about the fact of recycling valuable products in case in the chain, but just very much creating with this. So each one of them is going to have a role and is going to have a question. So I will start then with Veronica. Tell us how analytical research infrastructure, large-scale research infrastructure can help the business of circular economy, because this is what you do. And tell us a bit more about Remade and maybe how you can collaborate together. If you can do it in 2-3 minutes, it will be fantastic.
Yeah, no, I will be very brief, but to the point. I have attended different events where there were different stakeholders, policymakers, industrialists, and research technological organization. I think today there is a lack of understanding of the incredible and unique portfolio of technologies we have in Europe. And when I talk about this unique portfolio, I'm referring to synchrotron facilities, neutron facilities, laser facilities, positron facilities, and nobody really knows what we can really do about those technology, especially in industry. So with Remade, what we're trying to do under the umbrella of 49 research infrastructures in Europe is to join the forces and try to help the textile, the battery, the automotive, the packaging, the food, the electronic, construction sectors to figure out what they can actually do by going to facilities like ESRF, DAISY, Max4, ISIS, all facilities that some of you might haven't even heard before, some of you might be more familiar with. I believe that in a fast-paced changing society, where now technology is coexisting with humans, we need to be less scared of approaching advanced technology to solve problems.
How we can access?
The way you can access those facilities is through Remade. We have basically built a different access where we have a collecting point that you basically a single point that you reach out to us, and then you come to us with a challenge, we come back to you with a solution, and everything is for free. Except, like, your proposal have to be accepted by an external committee. You need to strategically, if you're a company, you need to select a key challenge for your organization that can help your organization to develop manufacture and waste your product in a circular way.
How you help industry in that?
Basically, you come with a challenge, and we have more than 100 team of scientists that will take the samples, will do the characterization in parallel with different technology all around Europe, and then they will come back to you with a report, detailed report of data analysis, and they will basically show you what's the value in it of using this advanced technology. And this is basically, the starting point. For a small, medium-sized company, this will be done all for free. Everything will be under no disclosure agreement. Nobody will be forced to publish any data. When it comes to the other access route, which is called Remade Ind, this is another interesting way to access facilities. Because if you're a company and you're not familiar with how you can use this technology, we allow you to collaborate with an institute, a research technological organization, a university, and we give you 30,000 euros to begin with, where you will start to...
So advising and unholding.
We guide you through, yes, you will never be alone.
So you have an expert group that is helping industry.
There is a science cluster team, yes, and then experienced scientists, and the institute that you will join, that you will collaborate with, they will be also experienced with the different technology. So at the end of the day, you only need to tell us what are you struggling with to make your product more circular, and then we will come back to you with the solution.
Great. I think stay with this. Solution, more circular, that's perfect. And of course, before we put on the, maybe I can go back and on you. This is the website of the project. Don't hesitate. Thank you. Okay, the way it's going to work here is that I'm going to ask a first set of questions, and then questions can come from the audience. So don't hesitate to start thinking about the question. No, the next question is for Lars. Lars, it's a pleasure to have you here because you are working on photovoltaics, even on the making photovoltaics lasting longer, and you are from Total Energy. So it's how fantastic is this association of photovoltaic, a company that is very much one of the leaders in the energy sector, and you are very much involved into this life cycle analysis. So how characterization can help you in doing this assessment of aging of these tools and devices?
Thank you very much, Ennio. Yes, I mean, characterization does play a key role, of course, in maximizing the energy output over the lifetime of a PV system, and that's what you want to do, because all the environmental impact that is generated by a PV system is related to the energy production by this PV system. So you always maximize the energy output over the lifetime, which means you want to have a long-lasting system and you want to have a high power conversion efficiency during the life of this system. And of course it means that your materials that you use to make a solar cell, to make a solar module, they must be very well characterized, and they must be tuned in a way that they have a maximum power output and a very long lifetime. So, for example, crystalline silicon is the most widely used material for making solar cells these days. And you need to minimize impurities, obviously, in the crystalline silicon. So, for example, the oxygen content needs to be as low as possible. You need to characterize your material as a starting material while you manufacture it. You need to measure the efficiency of the cell at the end of the manufacturing process. Then you need to characterize your module to make sure that you don't have any water vapor intake, for example, during the lifetime. So all this needs to be done in order to maximize the energy yield over the course of the life. And life cycle assessment, something that we are doing, is a way how to quantify the environmental impacts in many different categories.
Okay, so you do the life cycle assessment, or you work with the external companies, and during this life cycle assessment, you're doing this characterization all along. So I guess the characterization is supporting you in this. And tell me, it's worth the effort. It's not true that you spend more energy to build a photovoltaic cell than what is bringing in his entire life.
Of course. Well, the energy payback time, that's the point that you refer to, I mean, is very low, depending, of course, on the PV technology that you use, whether it's crystalline silicon or thin film technology, and of course, depending on the solar installation, so whether you're in Norway or in France, obviously makes a difference. But typically, you have energy payback times of less than 2 years, partially even less than 1 year. So which means in 1 year's time, the energy produced equals the amount of energy needed to manufacture the system in the first place.
And this can be well characterized. So
that's well established, has been characterized many times by many different groups. Yes.
Very good. Thank you very much. And now, since Antonio is just nearby, tell us what you do with your waste. The magic, the roi Mida
Yes.
of the material science.
What we are doing in this moment, and what we will do with our waste. So just some figures in order to make you understand if you are not useful with the process, the steel making process by electrical furnaces. Some figures. So we start from scrap. We use a lot of energy for melting it. Scrap is a secondary raw material. In this moment, we have a lot of scrap coming from Europe. But in the next future, there will be the war of scrap, because a lot of companies that in this moment are working with the integral cycle, so they use in this moment iron ore for the production of steel, will transform their process in the electrical cycle, in the electrical furnace process. So we will work in the next future with low quality scrap. So what we can do with low quality scrap, we will transform it. We will change the dimension. We will sort inerts. We will sort different kind of non-ferrous metals in order to make with this something other. So we need the characterization in this phase in order to characterize the right dimension of the scrap, in order to characterize the chemistry of the what we are sorting. This is for the upstream part. For the downstream part, so waste. In this moment, we are two different cluster of waste. Dust coming from fumes, from the fumes of the producer during the process. This dust is rich in zinc oxide. So in this moment we can recover it, and that can then start a secondary circular economy. At the same time, we are producing slag. Slag is something that we need during our process, because it helps us for reducing energy consumption, for reducing problems in the furnace and the refractory.
Slag, sorry, Antonio, is the thing that is floating on top of the melted steel?
Yes, something that is floating on the top and is foaming and floating on the top of the melted steel in order to protect the steel. This kind of waste, in this moment, we can recover it in order to produce asphalt, and in order to use it in the stabilization of soil, for example. But the added value of this kind of material is very, very low, and we are not talking about circular economy. We just increase the lifespan of this kind of waste, but at the end of the second implementation, we will landfill this kind of waste. So we are working in order to reuse it, use this kind of waste that is rich in oxide, magnesium oxide, silicon oxide, aluminum oxide, calcium oxide. And in order to produce, for example, filter for water, in order to collect and remove phosphorus from water, for example. And at the end of this implementation, we would like to use it in order to, like a filler in polymers or rubber. So we are trying to...
This is important. Give us an example. So you said there's going to be a war for waste. Actually, you're going to be the rich guy producing all this waste. So give us what you're going to do with this. Yes. An example that the filler, for example, will be interesting.
Yes, we can use it in order to reinforce polymers, to reinforce or change the color in rubber. This is the typical implementation, but we would like also to use it for the producing of fiber, because this kind of material, slag, is similar, chemical composition similar to the basalt. So we would like to use it for producing basalt fibers and use it in the fabrication, production of a composite, for example.
Okay.
And we need, okay, by the way, we need, and of course, characterization, mechanical characterization, for example, X-ray tomography, in order to understand better mechanical properties or other kind of characterization, in order to understand if our the dimension of the
Antonio, you sold it so well that I think we're going to trash the steel and we keep only the waste because it's so rich.
Exactly.
Thank you very much. And now I would like to give the chance to Julien to tell us a bit about how characterization can support the innovation in sustainable development, in case in new material coming from circular economy.
Thank you very much, Ennio. If I may, I would like to make us one step behind, just because the foundations are slightly moving. And I would like to come back on the life cycle assessment, because we all performing this kind of studies in our project. And I think we forgot one of the R, which for reduce. And it's one of the topics that can bring new design, let's say optimization to materials with less effort, but it implies to know the material itself, to quantify the right quantities, not too few, not too much. So this is the first part that we can work. Then obviously there's usage of it with the repair activity and what do we do with the material itself to extend its lifetime. And of course at the end there's the second usage, the recycling activity. So for example at the RT we are working on how can we dismantle some components once they have reached the end of life, just to provide them a new life with a limited mix of materials and help to use them directly as they are. So just
the design is very important.
Yes.
At priori, we don't have just to be downstream.
Yeah, that's right. So this is probably one of the first remarks that I would like to tell. The Tigomon is the specification itself. I have spoke about the specification. I think we live on specification that's for a part of them have been written for ages now, and it's quite a huge work to come back on the specification and try to eventually adapt it to the new context. So I get it. It's a part of the characterization because it implies to know your environment better as it evolves, but maybe because ages from this, you used to protect your product and you have made specification very high, and finally at the end you don't really need this, but you don't want to modify everything. So at the RT, for example, we make studies of comparing the accelerated aging versus the long-term in-service aging by using our data from our partner and using some numerical approach. We can correlate this model and propose optimization. Of course, not a new specification, but some way of optimizing it. So this was the two parts that I would like to
tune the expectation to the right application needs and not overdo.
Yeah, which brings me to your question of how to deal with new materials. And the answer is part of what I told is we see new materials arriving from bio or recycling sources. It's new materials that we have to characterize them, to know their properties, to take the best of them, and to try to find some reliability, to bring confidence to our partner, to prove them that they can use them. So, of course, characterization bring the data and bring help for the decision. And the other thing is, for most of them, he's a huge range of variability of the properties that you can expect. So, of course, using the characterization helps to narrow the spectrum of what you can take directly like this.
It's interesting. This characterization can help the decision,
yes.
which is not what we have said
Absolutely.
before. This is something new. You say, let's think before, and not just use the characterization to measure what is already there, but just use the characterization to think better.
Yes,
that's
right.
a very nice
Yes.
conclusion.
Mm-hmm.
Yeah. Thank you, Julien.
Thank you.
Maybe we can ask a first question from I have plenty of others, but I would like to give you a chance to ask something if you want. Yeah, please. Yeah, I do that.
Hi again. I think it's an open question to all the panelists. You mentioned that characterization can speed up maybe development of materials or new application. I'm just wondering, maybe it's a question to Antonio first, but I think it's an open question again. I'm just wondering how you select some service providers, some CROs, and do you think that it's necessary to develop a certification or something to increase confidence in data that are produced by such laboratories? Veronica mentioned that it's free of charge to perform large-scale measurement, but how can we explain to the industry the level of confidence and the quality of the data that are produced that can maybe ease exchange in all development of materials? So it's a large question.
Thank you. So the role of certification, basically, it's even going beyond. We were thinking in general about characterization. Yeah, maybe, yes. Antonio, thanks.
It's a good question. So in this moment, regulation, it's the very big problem, the very big issue. So certification have to evolve in order to help companies, industries, service provider to narrow the work that you have to do, you have to provide, and also in order to assess what you have to do what you have to do and what you have to improve it. In this moment, for example, I mentioned the utilization and waste of the slag for the utilization in the asphalt production. Regulation in Italy is very different. So in different region you can use it. In a region you can use it without problem. In other region you can. But the asphalt is the same that you are using in your highway. So it's a very, very the regulator and the certificator will have a very big role in the future for the circular economy.
We clearly need a more agile ecosystem for industries and RTOs and large-scale research infrastructure to work together. Because today, like during the last 10 years, this has been really one of the major challenges because there are the solutions, the challenges are clear, the solutions also are clear. Also clear the partners that can actually provide this service. And then all of a sudden, months pass by and there are issues coming from legal aspects. So something that is beyond what is actually the service that we're going to provide. So that's why it's very important nowadays to have everybody in the same room and find the best solution to actually move all together in the same direction.
And the answer is IRT.
Just a thought about that.
Everybody in the same room.
It's very difficult to have people at the same level of knowledge, maybe coming from different fields in the same room. Politics are very, very far in the space and the time respect to scientists, engineers, company, industry. So
Trust me, I'm a
that's the
doctor.
challenge.
Okay. Okay, last question.
Okay, so that Peter Rock, IPVF, and my question is related to what we have just discussed, regulation. Is regulation something which helps to speed up? And in fact, what we have in the title is speeding up. I think that's what we need for climate change. And so how do you see, what should we do? Okay, we are here together. Probably that's a good way to start. What else can we do to speed up?
Okay,
to have,
very good question. So regulation is even beyond certification. I would like to ask Lars and then Julian to answer, giving a bit the perspective of the industry and maybe more academia.
Yeah, I think we do need standardizations. We do need certifications in almost all areas. I mean, if I think about photovoltaics specifically, then if you think of new technologies that are being developed, you need to have test schemes for these new technologies in order to become bankable, in order to be able to deploy the technology in the field. Without standardizations, without certification of such technologies, you will suffer from financing issues of large PV projects, just to give one example. So in particular for novel materials, this is a very crucial point.
Okay, thank you very much. And encouraging. Julien.
I think I will be quick because I think we're out of time. Really? Okay. So my opinion is yes for regulation, but regulation not as a punishment. Regulation to go for the transition. I will give you an example. If in France, if you want to use a waste nowadays, you can't. As an industry, you have to go through a company. It's called ICPE for the partners who know this, and this company is charged of declassifying the waste into a new product. Obviously, years ago it was meant to protect, to not use a container for put milk inside, and we didn't know the life of this container. But nowadays things are changing, so the regulation is not ready, clearly, on several aspects, but we don't have to put regulation as a standard starting from nowhere. And I think the public authority have to support this transition, support to bring consortium, data, we spoke about characterization, and eventually new standards, like how can we certify new materials from waste, maybe from grades, in terms of purity, of properties, we can imagine of several ways. So yes for regulation, but I mean in the future ways, not from 0 to 1.
Thank you very much. Regulation and no punishment. And I think on this last statement, we should have stopped, but there is still a hand shaking, and I cannot say no to this hand.
On ne serait pas en France si on ne dépasse pas d'au moins une minute. Last question to Lars, maybe. You mentioned that you are performing a life cycle analysis at IPVF, which is a research institute. That means that you are doing this analysis on research prototypes where you probably face lack of data. You don't have access to established data from installed industry. So can you comment on how you address these issues? Because I think for all IRTs here, it's a very interesting topic in terms of how to provide reliable analysis without having all the data that you need to do that. To do.
Thank you for that excellent question, and it's indeed a source of uncertainty, of course. For example, if we are assessing the PV technology that is currently being developed by IPVF, we need to firstly rely on what the colleagues in the lab tell us about the manufacturing processes, about the materials that they are using, about the material stack thicknesses, and so on. And then we need to make assumptions about the performance of this technology in the field. So what will be the lifetime of the new technology in the field? And our assumptions will not correspond to the initial experiences, of course. We also have a source of information related to other technology components that are being used. For example, if we look at a novel tandem technology where you put a novel material onto a crystalline silicon solar cell, then the crystalline silicon solar cell part is very well established, and you can look into databases for that. But for the novel part, we need to project into the future. We do prospective LCA. We focus on processes that are being manufacturable in mass production. So we talk to materials suppliers, we talk to tools suppliers about the equipment being used. We assess the electricity consumption of this equipment and so on. In the end, we also do some sensitivity analysis around the most crucial factors to determine how the result of our life cycle assessment would vary if we go 10 or 20% higher or lower in certain values.
Yeah. It's interesting because we didn't talk so far about sensitivity analysis. So since I have the authorization to be a bit over time, I see a presence here on the screen, like the big brother. Marine, tell us.
Thank you very much, Ennio. I think the question is close to the one that was just answered, but maybe it can be broadened a little bit. The question is to the speakers, which is, from your point of view, the most promising characterization tool for life cycle assessment?
Okay, just the name of a tool, I would say Lars and then Julian in 10 seconds each.
Sorry, impossible to answer for me because life cycle assessment is a methodology that's being applied to many different products and technologies. So it depends on the product and technology you're looking at what the most crucial characterizations are.
Thank you. Julien?
Okay, so I can't shoot away now. I would say that to have a strong carbon database to compare what can be comparable, because each of you using different way of making the life cycle analysis and convert it into carbon footprint. So I would say the biggest tool for me is to the end of the chain, how to convert into carbon values and compare that can be comparable.
Thank you. We have a last question because I said no before, but then we went over time and for justice.
Okay, thank you.
If you can be short, that would be great.
It is very short. So everybody agreed, and we said about the quality assurance, about the importance of the characterization and the sustainability. But my question is, what is happening at the European level? Veronica just said that Remade is the first European project in circular economy. So if it is that important, why we don't have so far something more in this direction?
Thank you. Who wants to answer? Who have? Okay, Veronica. The final word is for you. Thank you.
Woman power. So, short answer. There are indeed different activities towards, a more circular economy in Europe. I think this was also a matter of discussion during the last Euro Nano Forum, whether we need better coordination between European projects that go in the same direction. But of course, when it comes to Remade, it is a unique project where large-scale research infrastructure will be used to support the industry, but also the academic in Europe, to make more circular products. So, yeah, it's relevant. So different activities actually go in the same direction, but we need a better coordination.
Thank you very much. Thank you very much. And on this is really the end. And thank you very much. Let's thank the panelists again. And all of you for participating. Very nice. And the panelists stay here because we have a picture.